Good news, Year 9. Just one little rule to learn today, and that's it. If I have a base being raised to a negative index, a negative power, then I can write that as 1 divided by that base to the positive power. Or, if I have just a number expressed with an index m, I can write it as 1 divided by a to the negative m. We better see why that works, then you're going to be able to use this rule, and it's going to be pretty easy. Let's consider just a nice simple example. A to the power of 3 divided by, well, I'm writing the 5 before I've written the a to the power of 5. Now, using our index laws from earlier in the chapter, when I'm doing division, my job is to subtract those exponents, 3 minus 5. What's 3 minus 5? Negative 2. So that could be written as a to the negative 2. I know I'm going across the page, and I don't usually like that, but it's only for the illustration of this. But we also know a to the power of 3 could be written as a times a times a. A to the power of 5, well, that's 5 a's being multiplied together. And you are well aware that you are allowed to cancel common factors. A goes in A once. Oh, they can cancel. This A can cancel with one of the A's down the bottom too. And this A can cancel with one of the A's down the bottom. So using just my knowledge of division, I can simplify this to 1 times 1 times 1 is just 1 in the numerator. 1 times 1 times 1 times A. That's just A squared, isn't it? Now, if maths is to be consistent, those two expressions must be equal to each other. Otherwise, the laws of mathematics would fail, and that would be a terrible thing for all of us. So, that's why it works. How does it come about? How do I end up with a negative power? Usually through division. So when you're doing your division, if you end up with a negative power, the question may ask you to express everything with a positive power. What do? You say, oh, a to the negative 2. That little thing, it's like a vinculum. It's reminding me to use the fraction, isn't it? And it's 1 over a squared. Because we know it turned up from division. Well, that's all there is to it. Let's have a look at these worked examples. Express each of the following with positive indices only. So x squared, oh, that's right. When it's a negative power, it becomes 1 over, and I can move that power down to the bottom, 1 over x squared. 3a to the negative 2b4. Here's question B. Let's just write the answer. Which one has the negative power? The 3, the a, the b, everything, some of them? If you think about it carefully, it's just the a that's being raised to that negative power. 3 doesn't have a negative power, it's just the number 3. B has a positive power, it's b to the power of 4. They stay right where they are. It's only the a that needs to go down the bottom. So I can just write that as 3 times b to the power of 4, all divided by a squared. Alright, there's a couple there for you to try. Pause the video, try them. See you in a few seconds. If I can find the pause. Have a check, see how you went. Yep, a to the negative 3, 1 over a cubed. And the second one there, part B, it's only the x that has the negative power. It moves down to the denominator to become positive. The 2 stays at the top, so does the y cubed. They didn't need to change, they already had positive powers. 2y cubed over x to the power of 4, and you're done. Let's go and have a look at the next examples. Use the rule. If I've got a negative power on the bottom, I can bring it back up to the top. That's just going to be c squared. I don't need to write 1c squared anymore. I don't need to write over 1 because there's nothing else down the bottom there. I'm done. This one here, ooh, the x has a negative power, so it's got to go down to the bottom and become x cubed. The y has a negative power, but it's in the denominator. It's got to move to the numerator. So each bit can just move up and down separately, because when we're multiplying and when we've got multiplication there, we're allowed to do it in whichever order we want, so that's okay. Part C here, the 5 doesn't need to move, the x cubed doesn't need to move, the y to the negative 4 needs to move. It's in the denominator, so I move it to the numerator and make the power positive. And that's all there is to it. So if it's got a negative power, move it from the numerator to the denominator, or the denominator to the numerator. If it doesn't have a negative power, leave it alone. 3 for you to try. Have a go at those now. And you can check your answers. Hopefully they match up nicely. Only a couple more examples before you can get stuck into these yourself. Evaluating without a calculator, express using positive powers only, then evaluate. So we're just going the extra step. Evaluate, we want a number as our answer. So when I'm doing A here, 3 to the negative 4, so that becomes 1 over 3 to the power of 4, which is 1 over 3, 9, 27, 81. We've got that, don't we? 1 over 81. Part B, negative 5 over 3 to the negative 2. Don't fall for the little trick here. Negative 5 is a number. It stays at the top. The 3 to the negative 2, it moves to the top. So negative 5 times 3 squared. Negative 5 by 9, negative 45. 2 over 3 to the power of negative 4. Hot tip, if I just find the reciprocal of that fraction, I can write this as 3 over 2, all to the power of 4. So that gets rid of the negative 2, because turning the fraction upside down has moved the 3 to the power of negative 4 becomes 3 to the power of 4 on the top, 2 to the negative 4 becomes 2 to the power of 4 down the bottom. So this is just going to be 3 to the power of 4 over 2 to the power of 4. We did 3 to the power of 4 just a few seconds ago. 81, 2 to the power of 4, 2, 4, 8, 16. 81 over 16, there's your answer. 3 for you to try. Pause the video, check your answers when we're done, and then you'll be right to get stuck into some work. Alright, and there you can see the answers there in front of you. So, hopefully that was okay for you. Just takes a little bit of practice. Don't forget quick points. Don't forget to keep those answers and the forms coming in and the questions going into the collaboration space. Can't wait to see you guys soon. Good luck with the rest of your work. Thanks. Bye.